All right, welcome to lecture 2 of week 16, where we're going to talk about coral bleaching and the threats to the reefs. So last time we talked about how reefs form and why they're so productive. This time we're going to talk a little bit more about what happens when they get stressed, when bad things start to happen, and how they're fragile and how maybe we can do some things to help them. So what is coral bleaching? Coral bleaching happens when corals lose their zooxanthellae, their algae. Without the algae, they lose their color and turn white. The, the zooxanthellae is the main source of energy for the corals. So what you're seeing when those algae are gone are that skeleton underneath, that calcium carbonate skeleton. Bleaching does not equal immediate death for the coral. Coral is still alive, but it's stressed and it can't really get very much energy without its zooxanthellae. So it's almost like coral bleaching is like a coral starving. We can think of it that way. Here's just a graphic about coral bleaching that I think is helpful, kind of shows what's happening here, some of the causes. We're going to talk about the causes more, but it's essentially showing the zooxanthellae being expelled and the corals without their color. All you're seeing is the skeleton. What are the causes of bleaching? The main one is elevated temperatures. Even an increase of only 1 or 2 degrees Celsius can trigger bleaching. It can be a big problem. Marine heat waves, essentially that's elevated ocean temperatures, right? But when that lasts for longer time than normal, that's a big driver of big bleaching events. Solar stress, so if there's more sunlight than normal, that generally means higher temperatures too, but the more sunlight even can cause bleaching sometimes. And then pollution like sediment runoff, poor quality water, they're not as big of a cause of bleaching, but they can increase a coral's vulnerability in general. So there's definitely a link to climate change with coral bleaching. We've talked about that a little bit already. And you can see these are corals that are in Hawaii that have been bleached, unfortunately. So then just a little bit more detail about how this happens and why. Water temperature goes up, and that makes the algae become inefficient. So when the algae is inefficient, it's not really working properly, and the algae produces these harmful compounds. You can essentially think of them like free radicals. It's a toxic form of oxygen, and they also produce sulfur compounds that are both damaging to the coral polyps. So in order to protect itself, the corals expel their zooxanthellae. So it's essentially a defensive response, but without their algae, the coral doesn't have their food. So it's this weird give and take, right? They don't want to have these harmful compounds and that are killing them, but at the same time, without their food source, they can't survive either. So it's a trade-off that, it's the best they can do. So now, can corals recover from bleaching? The answer is yes, it's possible, especially if the stress is short-term. If it's only a short-term rise in temperature, a short-term pollution, then the algae will return and the corals can recover. But if the temperatures don't return to normal, then recovery is much less likely. You can see this image here. Clearly, this coral is bleached, right? It was a beautiful coral. And this formation of red algae looks bad, but the red algae is actually a sign for recovery. The red algae essentially is acting as a landing pad for baby corals. It's a sign that the temperature is returning to where it should be. The coralline algae has it needs the similar conditions to what the corals need to grow, and so it's a sign of recovery. Whereas if you see green hairy algae growing on a coral, that's a really bad sign. That usually means that it's not going to recover, at least not soon. So what are some of the things that cause coral bleaching? Obviously, ocean warming. That's the biggest one that we've been talking about. Ocean acidification is also a huge problem because with acidification, the corals can't then build their calcium carbonate skeletons as easily. We'll talk about that a little bit more too. And we've talked about it already a little bit. Pollution and sedimentation blocks the light, smothers the corals. Essentially, they can't grow properly if there's too much pollution in the water or too much sediment. Overfishing disrupts the ecosystem balance. We all have talked about parrotfish and how they scrape the algae off of corals. Other fish do that as well, so overfishing can cause problems here. And coastal development increases runoff, causes physical damage to the corals. And of course, the direct human impact is a big deal too. When people are snorkeling or scuba diving and they touch corals, that kills them. I'm sure I've talked about this a million times before, but when people come, and I've seen people stand on top of the corals and just do, and I don't think people generally intend to harm them. I think they don't know. So education is a huge factor here to help with the direct human impact of the threat. This is just another infographic that shows many of the different threats and how they work together as well, which is important, and some ways that you can help. And we'll talk about some of those a little bit later as well, because that's important too, I think. Ocean acidification, we've talked about that before, so I'm just going to go over the fact that the carbon dioxide plus seawater makes carbonic acid, and that reduces carbonate ions, which the corals need to build their calcium carbonate skeletons. It lowers the pH, and the corals then grow more slowly and they're weaker, which makes them more vulnerable to bleaching and all the other issues. They all work together in tandem. NASA is doing a reef monitoring program. They have satellites that track the sea surface temperatures, heat stress on corals, and then their bleaching risk. And it matters because it can help predict bleaching events and help guide conservation efforts. So over time, maybe that can change things and how they're working. Here's just one of the maps from NASA showing sea surface temperatures in 2022 around the Great Barrier Reef. And anything in red is about 2 degrees higher temperature than normal. So you can see there's a lot of red here. There's some yellow and orange that's still higher than normal. Anything in blue would be lower than normal. So the only area I see that's blue is right down here. So obviously warmer means that those areas of corals are in danger of bleaching. Are our reefs in crisis? Evidence definitely shows that bleaching events are becoming more common and there's less time in between events, which means corals have less chance to recover, and we're seeing long-term declines in many, many areas. The Great Barrier Reef has had some very massive coral bleaching events, and we have had coral bleachings here in Hawaii in 2014, 2015, and 2019. So are corals resilient enough to keep up? I mean, I think that's the question that I ask you guys to think about in your discussion this week. So, I don't think we have an answer to that yet, and we'll see, I guess, is the answer. Key takeaways: bleaching is a stress response. It's not immediate death, but it does stress the corals and it is dangerous. The main driver is ocean warming. Recovery is possible, but the ocean has to go back to normal temperatures for corals to recover. There are multiple stressors all working together, so that can lead to more stress on the reef and make it less likely that they'll recover. And recovery is possible. And what we're going to look at next is Hawaii's reefs and what the future might look like. So I'll see you over there.